Okay, so these are the notes for greatest common factor. This is the beginning of a 2 to 3 week unit on factoring. Some of this we know how to do from radicals. Well, let's go ahead and go with these notes. So the objective is you're going to be able to identify the greatest common factor between two given monomials. Some vocabulary. A prime number, that is a whole number greater than 1, whose only factors are 1 and itself. We talked about prime numbers a lot when we did simplifying radicals, and we did prime factorization. So some examples of prime numbers, I want you to write some down. The obvious ones that you guys know of. Think about the numbers that we circled when we simplified radicals, and write some of those examples down. Did you get some of those? You should have at least gotten 2, 3, 5, and 7. Those are the most common ones. Right. And there are some more examples of prime numbers. Again, prime numbers' only factors are 1 and itself. So to factor a number, you're going to use a factor tree. So the example, it's not that example right there, but that is an example of a factor tree. We're going to factor out 90. And it's written right there on your notes. So you're going to break each number down until you can't go any further, and you should be left with all prime numbers. Anything that ends in 0 is divisible by 10, so 9 and 10. 9 factors down to 3 and 3. 10 factors to 5 and 2. And those are my prime numbers. So 2, 3, 3, and 5. Or 2 times 3 squared times 5. All right, to factor a monomial, you're going to break it down into the product, of its prime components, prime components. Into the product of its prime components. And we'll practice what that means. You're going to break each variable down so that it has no exponent that is greater than 1. Breaking each variable down so that you have no exponent greater than 1. And here's an example of factoring a monomial, and that's in the box on your notes. So we're going to pull out a negative 1 first to make that positive. So we don't usually factor with a 1, but if it is a negative number, we'll pull out that negative 1 to get it to a positive number. Factoring 12, 6 and 2. Factor 6, it's 2 and 3. Then we're going to factor our variables, a times a, and b times b times b. Take our prime numbers, are right there at the bottom, and we're going to multiply those to get our greatest common factor. Oops. So to find the GCF of multiple monomials, first you're going to factor each monomial. Then you're going to circle each factor that all of them have in common, the greatest common factor. So the one that they all have in common. And then you'll write the circled items on one line. So let's look at this example. You can turn your notes over. So here we're going to find the greatest common factor of these monomials. We're factoring 36 first, all the way down to its prime numbers. We write those on a line. Then we're going to factor 54. And the variables. The variables just get written out as expanded. And now we're going to look what's common in both of their prime numbers. 2 in common. We actually have 2 3's in common, an x, and a y. So what we circled here are the common factors. So we write those in a line. To get our greatest common factor, which is 18, 2 times 3 times 3, xy. So 18xy is the greatest common factor of those two terms. All right, another example. So we factor 25. Those are our prime numbers. We factor 21. And those are our prime numbers. And then we look to see what they have in common. They have nothing in common, which means they're both prime. Both of those terms are prime. There is nothing that we can factor from those terms. Those two numbers are prime, so they cannot be factored. And so the only common factor that they have would be 1. All right, so we're going to determine what the greatest common factor is of these two terms. And this is example 4. Oops, let's go back. So if you factor 16, so we have 2, 2, 2, and 2. We have 3 x's and 2 y's. Factor the 12. So we have a 2, 2, and a 3. Oops. And we have an x and 5 y's. Notice I'm lining them up so I can find the common ones easier. All right, we have a negative. We'll bring this negative 1 out because we want it to be positive. 5 and 8. 2 and 4. And 2 and 2. So I'm saying them just in case you can't read my writing on here. That was 2 and 4 and 2 and 2. So we have a negative 1, a 5. We have 3 2's. 1, 2, 3. 3 2's. And a 5. We have 2 x's. And we have 2 y's. All right. I know it looks a little sloppy, but if you're listening to me, you should be able to figure that out. So let's see what they have in common. I'm just going to put a line through what's common. Here's 3 2's, and I'll write them over here. 2. Here's another common 2. They have no 3's, no 5's. They do have an x in common. And really, I just need to look up at my terms, and I'm looking for the smallest exponent. So the most I can take out of all of them is 1x. The most y's I can take from all 3 are 2 y's, y squared. So there's 2 y's that they all have in common. So 2 times 2 and xy squared, my GCF here is going to be 4xy squared. That is the GCF. 4xy squared. All right, you're going to have some practice problems to try on your own. If you need to review this, and go back and review it a little bit. When you're finished with these 4 examples, you can raise your hand, or we may be just putting them on the board at the end. But please work through these 4 examples and find the greatest common factors.